Welcome back. So, this is the second part of the Fortran module, introduction to the Fortran module, and here we will learn the following three things. So, when one writes a code, this is something general in general, this is nothing specific about the Fortran code. So, one needs to repeatedly ask the code to do some stuff or a set of execute a set of instructions. Also, one needs to, in order to do that, what in Fortran, the first topic we will learn in this part is how to do repetitive operations, and these are typically done by these two variables, the do and the go to statements. Another thing which we often come across when writing a program is, for example, we want to execute a certain statement only if certain conditions are satisfied. So, we will also see in this part how to use conditional statements in Fortran using the if construct. And the third thing which we will cover in this part is, suppose I have a large number of a large set of numbers which contains similar information, and so in order to store them, we need to reserve space, and also we need to have different types of variable names. So, but for the same type of numbers, when I have a large set of such numbers, then what, instead of using individual variable name for each such numbers, I can use something which is called an array, and we will see what it is. So, basically the purpose of an array is it helps us in reducing the usage of a large number of variable names. Okay. So, to see how to do these things, we start with an example. So, what we are going to do in this example is we are going to generate a set of numbers, and such a set of numbers. So, for example, 1, 1, 2, 3 this way, and such a set of numbers is called the Fibonacci sequence, and it is a very famous sequence, and this sequence is used originally for modeling the rabbit breeding. You can find it in spirals, in seashells, the spiral formation, all those things can be explained using this Fibonacci sequence. So, the basic idea of Fibonacci sequence is it contains a series of numbers. It is an infinitely large series, and the way the series is generated is using this recurrence relation where. So, what this recurrence relation tells is that to get or to the nth number in this series, we need to know the n minus 1th number in the series and n minus 2th number in the series. If we add them, we get the nth number. So, this puts on a restriction on the value of x in the number. So, basically we start from, sorry, this will not be x, this will be n. We start from n less than, I am sorry, this is okay. So, the restriction is n greater than or equal to 3. I am sorry for the mistake in the slide. And my x1 and x2, that is n equals to 1 and n equals to 2, these are already set to 1 and 2. And another interesting property of this series is that the ratio of xn and xn minus 1, this always gives this number which is called the golden ratio phi. So, what we are going to do is we are going to write a program that generates the first 45 terms of the series and estimate the golden ratio. So, how do we do that? So, here is the algorithm. So, we will set the initial condition, that is, we will set x1 equals to 1, which is my initial condition, and x1 equals to 1 and x2 is also equals to 1, which is the initial condition. Then we initialize the iterator, because so to generate the third number we need to use the x1 and x2. Then to generate the fourth number we need to perform the same set of operations mentioned in this equation here, but by using now x2 and x3 and so on and so forth. We need to do this stuff repeatedly. So, that is why we need to have an iterator which can do this iterative job, and we need to have a counter also So, that will tell us how many times this iteration is done. So, we set that iterator to n equals to 1, and then the third step is we calculate that expression, the nth number in the series, and then we print out the nth value and the ratio of the n and n minus 1. And then once we are done with that, we increase the iterator. So, basically n will now be set to n plus 1. And what we do is, so we, as I mentioned, we want the first 45 numbers in this series. So, once the iterator is implemented, so the largest value of n should be 45. So, if it goes to so this step from 3 to 6, this will be repeated only as long as n is less than 46. And once we have done this increment, so what we need to tell the program is that okay, you carry on this till n takes a value, the value of n is less than 46, and what you need to do is till that value, once you reach this point, you need to go back to step number 3 and do the same process. So, how does the program design will look like? So, the questions here is what will be the data type for n and xn, okay? What variable names we can use, and the new thing which we are going to, so these two we have already seen in the previous part, and the new thing which we are going to learn in this example is how to implement step 6. So, the program design will look as following. So, we will use, so at a time, at a given instance of time, if you see, we always need 3 numbers xn, xn minus 1 and xn minus 2. So, and all these numbers are integer numbers. So, basically what we need is 3 variables we will be using here, x, y and z, where x I have assigned to, in x I will store xn, my new number, y I will store xn minus 1, the previous number, and at z I will store xn minus 2, which is the second previous number. And since these are all integers, I have set x, y, n all are as integers type. And the iteration step which I need to do, that is the mathematical operation which I need to do repeatedly is x equals to y plus z, that is sum of xn. So, this is nothing but you have xn equals to xn minus 1 plus xn minus 2. So, this is the step which I am doing. So, now once this is done, so for the second step, so that is, suppose I have done xn, now I want to do xn plus 1. So, for xn plus 1, what I will be having is xn plus 1 equals to xn plus xn minus 1. So, what it means is that, so what was earlier xn minus 1 will now become xn for the nth step. So, what we need to do is we need to set y to x as I have mentioned here, and what was earlier xn minus 1 for the n plus 1th step, this will be xn minus 2. So, and xn minus 2 I am storing in the variable z. So, what it means is that I have to set z to y as I have mentioned here. So, this is the basic design of the program, and how to look at the program, I have the example program here. So, what it will look like is the following. So, again as I mentioned in the previous lecture, so I start the program with this program thing, and then I give a name of the program. So, the program generates a Fibonacci series using this new Fortran function, which is a goto. So, as usual I tell the code or tell the machine that do not assume anything about the type of the variables I am using. Then, since I am dealing with only integer numbers, I am declaring x, y, z as integer variables. However, the ratio, one should remember, is a real number. So, I am storing the ratio of xn and xn minus 1 in this variable called phi underscore estimate est, which is a real type, and then n is my declaration of the iterator, which I set to 3, because so my x1 and x2 are always 1. So, once I have declared my variables, now I come to the main part of the program. So, first I set the initial conditions. So, remember z, as I mentioned here also, z is my n minus 2 and y is my n minus 1. So, for the first two numbers of the series are always 1. So, I have set z equals to 1 and y equals to 1 as the iteration condition, and then I proceed to compute the value of x, that is the nth number in the series, which is nothing but the sum of n minus 1 and n minus 2 numbers, and that is what I have done. So, basically in the variable x here I am assigning the sum of the variables y and z. So, once that is done, what I have done is, now I am estimating here the ratio which is stored in this variable phi. So, now notice one thing. So, here my x and y both are integers. So, had I written, instead of writing it like this, had I written that phi underscore estimate is equal to x by y. So, this division would have been a integer division, because x and y are always integer, x and y are integers here. So, I would not get the correct estimate of the phi. So, instead what I have done is, I have converted one of the numbers, so in this case y, to a real number. So, that now this mathematical operation, which is a division, will be done in terms of, will be a real mathematical operation instead of an integer operation. Then once I am done with estimating, computing the value of the phi, so I want to print three things here. So, first is the iteration number, that is the which number of the series this is, which is denoted by n. Then I print the number x, and then the estimate of the ratio of n and n minus 1. So, what I want to print is, I want to print two integer numbers and one real number. So, that is why in the form, and I want to print it in a formatted form. So, that is why within the format statement I have here, since I am having two types of numbers. So, I have two format statements, one for integer part and one for the real part, and for the integer part I am printing out two integer numbers. So, I am using 2 here, and then I am keeping a space of reserving a space of 15 for each of them, and then for the estimate of phi I am reserving a space of 10, and I am writing 5 places after decimal. So, once I have printed this value on the screen, so now I need to reset my variables. So, what was earlier y, that is x n minus 1, will now become x n minus 2, and I need to store it on z. So, here in this statement, in this line, what I am doing is, I am reassigning the value of y to the variable z, and in a similar fashion I am also reassigning the value of x to the variable y. So, once this reassignment is done, so I have my new sets of n minus 1 and n minus 2. So, once these are done, then I reset, I increase the counter by 1. So, this now becomes n to, so I reassign n by using this assigning statement. Basically, I am adding a value of 1 to the previous value of n. So, once it is done, then I come to this part of, so this is the new part which we are going to learn in this. So, here I have two statements, one is a conditional if statement and another is a go to statement. So, what this statement does is, the code checks whether the value of n is less than 46. So, as long as the value of n is less than 46, whenever controller comes to this line, what it will do is, it will go to a line which is labeled by this number 2. So, let us see where in the program I have labeled this line by 2. So, we can see that here is my leveler. So, what this will do is, the moment the controller comes here, the moment the machine reaches here, this part of the code, this last line, it goes back to the controller is taken back to this part of the code, and then the whole thing is again executed repeatedly. So, this is one way of doing a task repeatedly in a program, or telling the computer how to do a task repeatedly in the program. So, that is by using the go to label. So, you can write either together go to, this is the syntax, or you can write in a separate way, and also you should have the label which comes in the beginning of the line, but it is not always I mean this is one way to do it, but it is not the most efficient way and you can make mistake in putting the label. So, I mean for all practical purposes one should try to avoid this thing. So, another important attribute of the Fortran which we saw is the if statement. So, the syntax is very simple. So, what the if statement does is it allows us to perform a logical task. So, the syntax is very simple. I have if, then in the bracket I need to give a logical expression which if satisfied the code will do this following action. So, here in this way the if statement in this way we can perform only one action if the condition is satisfied. Now, suppose if we have to perform a set of actions if when the logical expression is satisfied, then how do we do that? So, in order to do that we use what is called the if construct block. So, the syntax is in the following. So, you start with if and then you have your logical expression. So, if that logical expression is satisfied, then you have this, then you go to block 1. So, block 1 basically contains a set of instructions. If however, this logical statement is not satisfied, then you can come to the next condition, that is by using this else if statements. So, the syntax is again similar, else if, then the logical expression, then if this logical expression is satisfied, then it comes to block 2 and so on and so forth. So, in this way one can put several else if blocks within the full if and the end if, but remember that the last block should be preceded by the else statement. This you should be careful of. So, once this is done, then you end the construct loop, the if construct with a end if. So, basically the point is one should remember that if you have a if, then you must have a end if. So, this is something which needs to be careful of. So, for example, this program shows the usage of a if block. So, I have two variables x and y, and what I want to do is these variables are typically numbers, and I want to check check whether if x is less than y, then I write down that the first number is smaller, and if it is not so, then the second number is smaller. This is what I want to do. So, how one does it? One does it through the if statement. So, I use the if construct in the following way. I check whether x is, so this is my conditional statement. I check whether x is less than y. If this condition is satisfied, then the code will do is will print this line on the screen. If this condition is not satisfied, that is if x is greater than y, then what the code will do is it will not execute this block, it will come to this block, and then it will write this statement that the first number is not smaller and then the program will stop. Also, in a program what might happen is you can have several and thousands of these if statements. So, to help you go help the programmer or the person who is writing the program to go through easily. So, what one can use is also something called the named if statement, that is for if each block which you are using you assign it to a certain name. So, this is done by the following way. For example, suppose I want to assign a name to this same block. So, what I do is this is the Fortran program which is doing this is my if construct. So, just before the if construct I put the label. So, the label is written in the following way: you give a name to the label followed by a colon and then you start your if construct, and once you are done, so after the end if you again repeat the name of the label. So, the advantage of this is this gives a clarity in your program and helps you in checking mistakes or debugging. Okay, so till now we saw how to execute conditional statements, and then also we saw one, I would say, crude way of doing a set of instructions repeatedly. So, a better and a sophisticated way to do it is using what is called the do loop. Now, the do loops are of two types. So, one which I am showing in this slide, this is infinite do loop. So, the code the syntax is the following. So, you start with a do and then you have a code block which carries the set of instructions that one needs to execute repeatedly, and then you have a end do. So, if you have a something like this in your program, so the program will never stop. So, it will continue executing it infinitely. So, basically what you need to do is you need to tell the program when to stop, and that is done by a exit statement. So, inside this code block you should put an exit statement something like this: if some condition is satisfied, then exit, to prevent infinitely carrying on with the set of operations in the loop. So, the moment this condition is satisfied, what the controller will do is it will come out of the end do loop. You can also have finite do loop, that is, you can restrict or the number of times you want to execute a set of statement, and the syntax for this is very similar to the infinite do loop, only the new part which is present here is this 4 set of integers. So, basically the first one, this my variable here, my var, this acts as a counter. So, for example, I can write, say, if I is my counter. So, then I tell the code how many times, from which value the counter should start and till what value it should go. So, I can say, for example, the counter should start from I, which is the minimum value here, this variable, and say it should go to 30, and then I have my set of instructions here, and then I put the end do. So, in this case, after every time this set of instructions which are present here is executed, the counter, the increment is 1. So, basically I is set to the code automatically sets I to I plus 1, but suppose I do not want that, I want the increment to be 3. So, basically what I want is the counter should go from I equals to 1 to I plus 3. So, how do I do that? Then I add another number here which I say is 3. So, this is this number here. So, this is basically the increment of the counter. So, this tells the code that you increase the counter by this number n, and as I mentioned before, the default value for the same is 1. Another thing we should keep in mind is all these 4 variables which you are using, that is the counter, the minimum value of the counter, the maximum value of the counter, and the increment, all these should be integer numbers. And similar to the if block, you can have many do loops nested in one inside the other. For example, suppose I have a do loop I equals to 1 to n, then n do, then I can have another, I can start another do loop which starts from a different counter, say I to n, and I have a set of operations like that in this. So, you can have several do loops inside one main do loop. So, these are called nested do loops. Okay. So far we have seen how to execute conditional statement and also how to ask the program or the computer to do a set of instructions repeatedly using the if construct, the go to statement, and the do loops.